What is up, calculus students? I'm making this video pretty much for Shadi and Sahota. This is for you guys because you complained about the last video. But I understand the old videos where you can't see my face, not as engaging as these new videos. So here we go. Step 2. Are your critical points indeed maxes or mins? We discovered that if you understand the signs of your derivative, positive, negative, negative, positive, whatever. I'm just putting something randomly. You know your function's got to be increasing or decreasing. If f prime is positive, f is going up. If your slope is 5, f is increasing 5 y's per x. If your slope is positive, your function must be increasing. If your slope is negative, your function must be decreasing. Remember, f prime slopes, the slopes of f. Okay, cool. So we have done step 1. We have found our critical points. Here is step 2. Analyze the signs of your derivative. You have a critical point. F prime sign is 0, or f prime's value is 0 at 5, 6. That's a critical point. That's negative. Add 5 divided by negative 6. I always start off and get answers wrong. Then all we need to do, understanding that if we found all the critical points, the signs on intervals are going to be consistent, plug in test points into your simplest derivative. Now, this is not factored because it doesn't have, it's not really factorable. I guess I could pull out a negative 5 if I want to. But anyways, think about plugging in values to the right and to the left of our critical points. Values like 2, you plug it in, negative 12 minus 5. I don't care what the value is, but I know negative 12 minus 5 is a negative. I know all values are negative. If I plug in 0, 0, negative 5, 6. If I plug in a value like negative 2, negative 6 times negative 2 is positive 12. Positive 12 minus 5 is going to be a positive. Okay. This is telling me f increases, then decreases. This is telling me that x equals negative 5, 6 is a max. Hooray. Okay? That's it. This is step 2. This was step 1, last class. This is step 2, today's class. But obviously, you got to be able to do both, unless we have one of those questions where they're giving you both. Here we have critical points at negative 2 and negative 4. Great. Step 1 done. Step 2, analyze the signs. Make sure you put your values in the correct order. Okay. We don't care about the value. I don't care what the number is. The number is important. The actual slope value, plugging in 1 and getting 5 times 3, 15. The slope of this at 1 is 15. It's telling you how quickly you're increasing. We don't care about the value right now. We just care about the sign, okay? The signs of f prime. So don't plug in test points into your original f prime. Plug it into your simplest f prime, your factored f prime. Plugging in something like 0. Notice how small I'm writing it so you don't get confused. Make sure you put down that these are zeros. These are when we flatten out. 0 slopes, we're constant, we flatten out. If I plug in 0, I got a positive 4 times a positive 2. Positive times positive, positive. If I plug in negative 3, positive, negative. Negative 3 plus 4 is positive 1. Negative 3 plus 2 is negative 1. So positive times negative is negative. If I plug in negative 5, negative, negative, positive. What is that telling me? F is increasing, then decreasing, then increasing. What does that tell me? That x equals negative 4 is the location of a max because I'm going up, flattening out, then down. X equals negative 2 is a min. Great. Now, After doing a bunch of test points, you see signs change a lot. They don't always change. They will here, they won't here. If you understand multiplicities of zeros, you know whether or not you're going to have sign changes or not. You don't have to do test points everywhere. If you understand multiplicities, you could have just found this positive and then known that your multiplicity of -2 is 1 and your multiplicity of -4 is 1. When your multiplicity is 1, it's like y equals x. You pass through and you will change signs. If your multiplicity is ever even, like x squared or x to the fourth, you won't change signs. Taking values and squaring it, the signs will always stay the same. It'll always be positive or like always be negative, depending on the leading coefficient or whatever. So you could fill out these sign charts using multiplicities. It might be quicker. I'll show you that for the next two. Now, if you are not comfortable with sign charts, comfortable with multiplicities, don't use them. If you are not comfortable with multiplicities, use test points. Here's my factored f prime. I'm finding my critical points. If there was a denominator, I would set it equal to 0. I get 0 and 6. These are my zeros of f prime. Throw down f prime because starting next class, we're going to be looking at f double prime. So we got to make sure we know what we have. Label things, please. Now, the multiplicities are both 1. So watch what I could do. I could start all the way here to the right when I plug in 7 or 8 or 9 or 10. Positive 6 minus 7 is a negative. So positive times a negative. I know I got a negative. Cool. I know I have to change signs. Why? Because the multiplicities are all 1. If I'm to the right or to the left of 6, this is going to change signs. If I'm to the right of left of 0, this is going to change signs. If you're uncomfortable with that, use test points. If I plugged in 3, I'd have a positive and a positive. If I plugged in -1, I have a negative times a positive. Okay, now again, what does that tell me? F goes down, goes up, goes down. X equals 0 is a min. X equals 6 is a max. There are other ways to actually figure out that we have maxes and mins at these locations, but this works always for any type of function, which is why we do this. Put my feet up. Oh. Okay. 2x squared minus x cubed. Make sure you know how to take the derivative. The 3 times the 2/3 is 2. The 4 times the 1/4 is 1. Setting this equal to 0, factoring out x squared. All right, our first indication of a multiplicity that is not 1. Here, x equals 0 has a multiplicity of 2. X equals 2 has a multiplicity of 1. Now, what does that mean? The following. If you were to plug in values to the left and right of 0, you're going to square them. It's going to be positive. It's not going to adjust the sign of what we have. The only thing that's going to adjust the sign is this 2 minus x. Watch what I mean by this. If I plug in 3, positive 2 minus 3, negative. Positive times a negative, I got a negative. If I plug in 1, positive times a positive, cool. That's a positive. I know we're not going to change signs. I know these are going to be positives. How do I know that? Well, either the multiplicity of 2 or if I plug in -1 and square it, -1 squared is a positive. 2 minus -1 is a positive. Okay, my signs do not change. So you could do that. You could do test points, or you got your negatives to the right of 2. You know your multiplicity of 2 is 1. You will change signs. You know your multiplicity of 0 is 2. You won't change signs. That is telling you f is going to go up, flatten out, go up, go down. Now, sometimes it's tough to understand whether you have maxes or mins. You can always sketch kind of what's going on. F is going up, going down. That's what f looks like. F goes up, down, up. Okay, boom. That's how you can kind of tell you have a max and a min. the arrows help you with the sketch. You don't need to sketch. But maybe here it's helpful because you're going up, you flatten out, you go up, you go down. So this is our first situation, and we saw it in our notes, of a neither. Critical points, possible max mins. Boom. There is a critical point that is not a max or a min. Let's keep going. Test points or multiplicities. In the future, multiplicities won't be able to be used all the time. Make sure you're comfortable with your test points, as they always work. So let me just use test points here, and then I'm going to start using some multiplicities. 0 and 3. These are the signs of f prime. These are where I flatten out. To the right of 3, 4. Positive, positive. Between 0 and 3, 2. Positive, negative. To the left of 0, negative 1 squared is positive. Negative 1 minus 3 is negative. Just to the right and left of 3, we change signs. To the right and left of 0, we do not change signs. This factor always will be positive because we're squaring. If this is a negative in front of it, it would be always negative. Okay? All right, same situation. F decreases, flatten it out, decreases, increases. So we have a situation where we come down, flatten out, come down, come back up. We're being a human graphing calculator. X equals 0 is a neither. And x equals 3 is a min. Let's see what we got here. This is one of those things, guys, where if you're not comfortable factoring, if you're not comfortable taking a derivative, if you're struggling taking these derivatives, you're not going to have a good time. Like, you can't get to step 2 if you can't do step 1 right. So vital for all of y'all who are just watching this video and copying this down. Stop copying this down. Actually do this homework. Struggle, make mistakes, fix mistakes, learn, get better. That'll lead you to success. You don't do that, it's still going to be a struggle. All right. All these multiplicities are 1. I know we're going to be changing signs. All of these multiplicities are 1. This multiplicity is 1, 1, 1. So that means to the right and left of all of these zeros, my factor is going to change. It's going to change the sign. So if I plug in something like 6, positive, 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 that's a positive. Change signs, change signs, change signs. Let's make sure that we're correct. Let's plug in something like a half. If I plug in 0.5, 0.5, 0.5 minus 5, 0.5 minus 1, positive times a negative is a positive. This is good. F goes down, goes up, goes down, goes up. X equals 0 is a min. X equals 1 is a max. X equals 5 is a min. Cool. Now we get to tougher ones. Trig functions. What are we going to do trig functions? Well, same thing. Let's do step 1. Cos x plus a half equals 0. Now to solve this equation, I got to subtract the 1/2. And I get cos x equals negative 1/2. I got to remember our unit circle. What are the angles when cosine is equal to negative 1/2? So cosine is equal to 1/2 at the tall 30, 60, 90 triangle. So that's at a pi over 3. I need my pi over 3s when cosine is negative. All students take calculus. So this pi over 3 and that pi over 3 is when cosine is negative. That's at 2 pi over 3 and 4 pi over 3. Great. Now, this is where things get a little bit trickier because it's like, what's my multiplicities, Mr. Messner? What's going on here? Well, it's not like the other ones where it's all factored and nice to work with. What do I do now? Well, hold the phone, make sure you understand what's f prime. This is not f prime. That was an equation that we solved. This is f prime. Cos x plus a half. Okay? Cos x plus a half is f prime. Okay. Now, I'll tell you that the signs will change. There's nothing crazy going on. Cosines obviously like changes signs, flips, goes up and down, up and down. But double check. What do I use for a test point in cosine x plus a half? Ugh. An angle. An angle that's easy to use, like an angle 0, like an angle pi. Between 2 pi over 3 and 4 pi over 3, you find the angle pi. Like an angle 3 pi over 2, or even 2 pi. All angles can be plugged in. If I plug in 0, I get the cosine of 0, which is 1 plus a half. That's definitely positive. If I plug in pi, the cosine of pi is negative 1 plus a half. That's a negative. If I plug in 3 pi over 2, the cosine of 3 pi over 2 is 0 plus a half. Positive. So like you could plug in values. Again, you don't care what exactly they are, but it is easy to find if you use nice angles as your test points. Now you notice that the signs do change. There's nothing going on. So if you just took one test point, you could be pretty comfortable in saying, okay, the signs are going to flip. So f is going up, going down, going up. X equals 2 pi over 3 is the location of a max. X equals 4 pi over 3 is the location of a min. Well, look at this guy for fun. Kind of like curves upward because of adding this thing. And we're only looking between 0 and 2 pi, so I'm going to change this to be between 0 and 2 pi. All right, cool. That's nice. So, bam. See that max? 2 pi over 3, we hit a max. It's nice that they did that. Bam, 4 pi over 3, we hit a min. Yeah! Math. It's exciting. All right, do this one. You didn't do the last one, do this one. So many points you can plug in. It's all going to work out to be the same sign. Let's see. Plug in pi. Sine of pi is 0. Minus 1 negative. Plug in pi over 2. The sine of pi over 2 is 1. Make it negative minus 1. Negative. The sine of 0 is 0. Minus 1. It's negative. We honestly should actually be starting at 0 and ending at 2 pi. There's like a start and end here. But they also could be test points. Don't worry about it. It works out. 2 pi. Sine 2 pi, 0. Minus 1. Negative. I'm thinking there should be a sign change. And I'm like second guessing myself here. If I plug in pi. Sine of pi is 0. Minus 1 is negative. If I plug in 2 pi, sine of 2 pi is 0, minus 1 is negative. All right, I think I have a neither. I honestly do. I think I have a neither. I think I have a neither because this it ends up being like a minimum. This is cool if this actually works out. So what I said about trig functions changing sign, I was completely wrong about. Let's see. Cos x minus x. 0 and 2 pi. And look at that sucker. What was our value? 3 pi over 2. Oh, right there. Look at that, right there. We decrease, we flatten out, then we decrease. It's a neither. All right, never mind. Don't assume that the signs change. All right. Hey, look at this one. Bring back our old friend. Do you guys remember? The O's and the I's, they're not going to disappear on you. They're going to come back when you least expect them. The derivative, 3, we can multiply the 3 and the 2x. Give me 6x, x squared minus 1, what starts the parentheses, squared. Setting this equal to 0, probably want to factor this to be x plus 1, x minus 1. But that x plus 1, x minus 1 is being squared. Fun. That's important because -1, 0, and 1 being all of our signs, but the squaring means the multiplicity both of -1 and 1 is 2, which means we're not going to change sign. We're only going to change sign at 0. So it'd be like plus, plus, minus, minus, or something like that. Let's check. 0's here, 0's here, 0's here. Plugging in 2, positive, positive, positive. Okay, everything's positive. Plugging in a half, positive. All right, whatever this is, I'm going to square it. So yeah, it's going to be positive. Plugging in -1, yeah, that works out because like whatever I plug in, x squared minus 1, I square it. I do get +1 and -1, but the multiplicities of both of them are 2. So this is cool. My function is decreasing, flattening out, decreasing, hitting a min, increasing, flattening out, increasing. I got to look at it. It's fun to look at this stuff. You are a human graphing calculator. I think that we are. Need to look around. Word. Cubed. Decreasing, flattening out, decreasing, hitting a min, increasing, flattening out. That's great. Isn't that great? That's just great. Just great. So x equals 0 is a min, and then x equals -1 and 1 is a neither. Oh, our friend. Our friend. Friend, you remember these were on your homework yesterday. What I didn't do, which I should have done, is use a common denominator. We always kind of just on the last homework video said, hey, x equals 0 is a critical point because if you plugged in 0, you got an x in the denominator, you're going to get 0. And that's fine. Honestly, that's fine. Like, x equals 0 needs to be looked at. It's a critical point. Add 1/3, flip both sides, you get 2x to the 1/2 equals a 3 after you add 1/3 and then flip both sides. Try it, it works. X to the 1/2 equals 3/2. X equals 9/4. Okay. So I square both sides. I get x equals 9/4. These are good ones to do, team. Just letting you know. For your quizzes, there might be like one tricky one, but most of them are like polynomials, easier to do. Okay, now what's fun about this is nothing. Yeah, actually, to do a sign analysis, a proper sign analysis, it is helpful if you have a common denominator. I'm going to give this a 3/3. I'm going to give this a 2 root x, 2 root x, giving me 3 minus 2 root x over 6 root x. Okay, this is important. Why? Because it's easier to look at the signs here. Now, Mr. Messer, like, how do I use test points here? And again, this is like one of those cases where multiplicities isn't going to help you. You got to use test points. One's a good test point. Why? Because I know what the square root of 1 is. I get 3 minus 2 over 6. 9/4. Oh, what do I plug in? I don't know. Something that's easy to take the square root of. 16. 3 minus 2 times the square root of 16. I know that's negative. Think about it. 6 times the square root of 16. That's positive. So that's positive or negative? It's negative. Square roots of numbers are positives. It's when we use a square root to solve an equation that the original value could have been positive or negative. I'm not going to plug in anything to the left of 0. Why, Mr. Mester? And I should have said this at the beginning of this problem. You're not allowed to plug in negative values into square roots. You get the imaginary numbers when you plug in that. So we're not going to worry about that. 0 is a good place to start. It is a critical point. 9/4 ends up being a max location. Squirt. So bam. 2.25. That's the location of the max. 2.25. Cool. Again, these are good practice, but they're a little bit on the tricky side. Now, what I didn't do in the last homework video, which I recommend doing now, common denominator. Honestly, common denominators are going to help you so that you can check your signs. It's easier to do that. I'm going to give this a 3x to the 1/3. Okay. 2 plus 6x to the 1/3 over 3x to the 1/3 equals 0. I get x equals 0 because I'm also looking for my undefines, my ins. 0, actually, we can plug in things to the left and right of 0 because you're allowed to cube root things. So 0 is a good number. And then 2 plus 6, x to the 1/3. So if I subtract 2, divide by 6, I get x to the 1/3 equals negative 1/3. I cube both sides, I get x equals negative 1/27th. Not plus or minus. Oh, it's a 2. No, yeah, the 2/3 comes down, subtract 3/3, it's negative 1/3. So let's go. So I get negative 1/27th and I get 0. Okay. What do I plug in? Values that are easily cube rooted. 8. Cube root of 8 is 2. Okay, that's easy. Okay. Positive. Negative 1. The cube root of negative 1 is negative 1. So if I plug in negative 1, I get 2 plus negative 6. That's a negative. And I also get negative 3. So I got a negative over a negative. So that's actually a positive. So that goes there. Oh, shoot. Yo, I wasn't paying attention. Negative 1's to the left. What do I plug in between 0 and negative 127th? Something that's easily cube rooted. Negative 1/64th. Why? 4 times 4 times 4 is 64. If I plug in negative 1/64th, let's see what I get. Okay, so I got this is too tough. 2 plus 6 times cube root of 64 is 4, so this is negative 1/4. This is 2 plus negative 3 halves. This is 2 plus negative 1.5. That's a positive. Over 3 times negative 1/64th to the 1/3. That's going to be another negative 1/4 times 3. That's a negative. So I got a positive. Okay, I get negatives. So negative 1/27th is a max and 0 is a min. I don't know. I got to move on, though. We got to get to the good stuff, the graph problems. I might just say, don't worry about the next one. Oh, shit. Look at us. 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 Negative 1/27th is right there. And right there we have a min. Who would have thought? Not me. I'm skipping this one. All right, cool. On the very advanced side, more reasonable. Definitely reasonable. Definitely reasonable. Both of these, okay? Probably just like good challenge. Cool. Moving forward, make sure you see what you're given. You're not always going to be given F on your 3.1 quiz. You weren't given F on one of the mean value theorem problems. You were already given F prime. You didn't have to take the derivative. You had it. Look, I'm already given F prime. The question is F increasing or decreasing at x equals 1? Well, if F prime at 1 is positive, F is increasing at 1. If F prime at 1 is negative, F is decreasing at 1. I don't even have to do the whole step 1, step 2 business. I actually just have to figure out what is the sign of F prime at 1. What is the slope at 1? If I plug in 1, I get 1 times negative 2 to the 4th times the cosine of pi. This is 2, 4, 8, 16. This is negative 1. You get negative 16. Now, I don't actually care about the value, but it is telling me how quickly things are changing. The slope of F at 1 is negative 16. F is decreasing 16 y's per x. What's the question asking me is like, are we increasing or decreasing? We are decreasing. Why are we decreasing? Because my slope at 1 is negative. That's it. Oh, look, I have F prime. Oh, you already gave me what I needed. You already gave me something. I just have to find the zeros, easily found. Do my sign analysis. We're back in the multiplicity land. X equals 2 is a multiplicity of 2. Since we're squaring, the signs aren't going to change to the right and left of 2. X equals negative 2 and x equals 0 both have odd multiplicities, which means the signs do change. Cubing things, you retain signs. Negative value cubed is negative. So plug in 3. Positive, 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 positives. We are not going to change signs. Are you not comfortable with that? Use a test point. We are going to change signs. We are going to change signs. Cool. F is going up, going down, going up, flattening out, going up. X equals negative 2 is a max. X equals 0 is a min. X equals 2 is a neither. What tells us if something is increasing or decreasing? The sign of its derivative. Why did I say that now? Why did I say that at the beginning of the lesson? Because watch this question. This is the challenge. When is f prime decreasing? We're going to talk more about f prime increasing and decreasing next class. Well, if f prime is decreasing, f prime's slopes have to be negative. Ooh, that's going to actually tell us about what f looks like a little bit more. We'll be able to be better graphing calculators after the next lesson. But here's f prime. When is it decreasing? Look at its slopes when they are negative. So I actually need f double prime, which is f prime slopes. 3x squared plus 6x minus 9. Factor to 3. Factor x equals negative 3 and 1. Positive, negative, positive. F is increasing, decreasing, increasing. When is f prime decreasing? Between negative 3 and 1. F double prime is positive, negative, positive, which tells me f prime is increasing, decreasing, increasing. We do this all next class. We look at when f prime is increasing or decreasing by looking at its derivative. If f is this, when is f prime decreasing? Again, f prime will decrease when its slopes are negative. It's very important. So let's take a derivative. Everybody's like, oh, we took the derivative. We're good. Oh, this is where it's tricky. The signs of f double prime will tell you about f prime increasing or decreasing. I actually have to go a second time. This kind of is a segue into next class. We will be finding when f prime is increasing or decreasing, because when f prime is increasing or decreasing, it tells us about the curvature of f. So, coming soon on the next episode of AP Calculus AB. F double prime signs tell us f prime's direction. F prime is decreasing for x values less than negative 1. Great. Now, the tricky ones. Everything was good probably up until here. You probably did a couple of these and you like panicked and you're all freaking out, but I'm telling you this is probably too hard. This is definitely too hard. It'll be fun to look at. We did a good job doing it. Test points are important. Tricky, make sure you know what you have. You know, these are fine. Hopefully we're okay with that. Use test points. These we should crush. Don't mess up on the polynomials, okay? But now we get to these graphs, and the bane of a lot of students' existence in Unit 3 is going backwards. What do I mean by going backwards? In Unit 2, I gave you F's graph, and I said, hey, F's graph looks like this. And you're like, oh, okay, let me sketch F prime. And you're like, okay, positive slopes, less positive, less positive, less positive, 0, negative. So you looked at a lot of slopes. And you're like, okay, positive, less positive, 0, okay. And you're like, oh, there's my graph of F prime. I'm giving you F prime. I'm asking you what's going on with F. What's going on with F? You're going to be given F prime, and you'll need to work backwards. Now, there are ways to do this where you're looking at like maybe signs and or powers, and you're like, oh, this is a quadratic. So that means since it's a derivative, my original equation has to be a cubic. That kind of works. That's a good little way to double check things. But I'm instead going to kind of approach it a different way. If this was one of the questions for the first 2 pages, you'd be doing step 1. And step 1 is like, okay, you're going to find when your derivative equals 0. Now you had to take the derivative, set it equal to 0. You got that. But like, now let's look at the graph. That's the derivative. When does the derivative equal 0? Well, here and here, f prime equals 0. So that means like the slope of f is 0. That's like, imagine we had f. Wherever we had a horizontal tangent, we'd put a 0 down there. F prime equals 0 here. And what would you do then? You'd say, okay, well, f prime equals 0 at -3 and at 2. Let's analyze the signs. Now, going forwards, you looked at slopes. You looked at the slopes of f and you plotted f prime. Going backwards, we don't look at slopes. Not yet. We're going to do that actually later. We'll look at different things later. You instead look at f prime's values. It's like if I gave you the graph of f prime and I said, hey, f prime looks like that. You'd say, okay, well, f has a slope. Again, these are slopes that equals 0. That means I have to like flatten out somehow. I got to flatten out. Before it, my slopes are positive slopes. These are positive slopes. Okay, so I have to be increasing. I have to flatten out. I have to decrease. That's like the idea. It's like you look at these values, these M values, and that tells you about.
Please pardon this interruption. We are excited to announce your official 2023 Homecoming Court nominees.
Yo, if Mickelson doesn't get this, I'm going to be upset.
Your Prince nominees are Ezra Once and Christian Inver. For Princesses, it's Riley Hewitt and Ava Cowren. For sophomores, the Princes are Andrew Brown and Jaden Anzadula. And for the Princess nominees, it's Hannah Brewer and Annabelle Clark. For the Junior Prince nominees, it's Trey Richards and Callum Gardner. For the Princess nominees, it's Lillian Howard, Sienna Watson, and Lena Scott. For the Senior King nominees, you have Benton Guggenheim, Tyler Ligon, and Grant Nicholson, and Jack Cheney.
Nicholson, there we go.
Your Queen nominees, you have Lily Peters,
Cheney,
King,
represent.
Shelby Jones, and Olivia St. Peter. Congratulations to all of our 2023 nominees. Freshmen, sophomores, and juniors, please check your emails next week for voting links to finalize your class's official Prince and Princess representative. Go Cavs.
Okay. Congrats to all the nominees. F prime equals 0. Going backwards, you're given the graph of f prime. You're looking at the values, the slope values. There are my zeros. When f prime is above the x-axis, f prime is positive. When f prime is below the x-axis, f prime is negative. To the right of 3, you might be thinking these are positive slopes. No, I'm thinking they are positive values. Between 0 and 2, you might be thinking, oh, I got negative slopes and positive. No, between 0 and 2, f prime has negative values. Between -2 and 0, oh, it's like positive. No. We're not going forwards. We're going backwards. Look at the values of your slopes, and that will help you create the graph of f. These values are positive values. They're positive, they get more positive, and then less positive. To the left of 2, you might be thinking these are, no, don't look at slopes. The values are negative. They are more negative to less negative to 0. F has to decrease, increase, decrease, increase. Let's think about that. I'm going to sketch it. Decrease until -2, increase until 0, decrease until 2, increase after that. Does this make sense? It did. If I gave you this was the graph of f, you would graph f prime, and you'd get that graph f prime. Now going backwards, look at f prime slope values, signs, you'll know what f does. Okay? So x equals -2 is a min, x equals 0 is a max, x equals 2 is a min. When is f decreasing? X is less than -2, negative infinity, -2, 0 to 2. All right, I gotta finish this in 5 minutes and get out of here. Beat the traffic. Zeros, zeros, zeros. That's the critical points when the f prime equals 0 or is undefined. So what are the critical points? X equals -2, 1, and 3. There are 3 critical points. Where do we have maxima? Now, this is not extrema. This is just maxima. Well, if you want to, since we're not talking about everything, watch this. I'll show you a little trick here. When is f prime changing signs from positive to negative? That's when f going to be increasing and decreasing and have a max. When does f prime change signs from positives to negatives? Here, x equals 1. You could do the whole sign chart and do it, but it's not necessary. Especially when we get to lesson 4, like sometimes not doing a full sign chart really saves a lot of time, and it's easier to understand. Like when is f decreasing? We can go straight to the chart and our understanding. F decreases when its derivative is negative. Okay, here is f prime. When is f prime negative? Well, f prime is negative when its y values are negative. These are f prime when the m's are negative. These are negative m's. 1 to 3. You can answer this question without having to do the whole sign chart. Last 3 are a little like trickier because I'm throwing like some undefineds in here and the sharp point. Like, don't freak out. Just do what we would normally do. Now, the critical points, this is good. When our derivative is 0 or undefined. Here is a 0. Here is a 0. This is an undefined at 1. I would consider that a critical point. Where do we have a min? Great question. A min will occur when f goes from down to up. F prime changes signs from negatives to positives. When does f prime go from negative values to positive values? Well, right here, I'm going from positive values to negative values. Right here, I go from negative values, probably a sharp point, to positive values. X equals 1 is that location of that relative min. This chart can kind of lead you to look at the graph so you understand. You don't have to sketch it. If you wanted to sketch it, it would look weird. What would the sketch be? Why don't we do this real quick? Positive values until -1, negative in values until 1. Very sharp change to positive values, flattening out positive values. So I'm thinking this is what the graph would look like. F is increasing, flattening out, and decreasing. Undefined, probably a sharp point, increasing, flattening out, increasing. So increasing, flattening out, decreasing. Sharp point goes straight to increasing, flattening out, increasing. This is what my graph of f would look like. We don't have a tangent slope at this sharp point, but we could say we have negative slopes followed immediately by positive slopes, getting less positive, flattening out 0. You don't have to be able to sketch it though. Where does f have extrema? Well, you can either say f prime changes signs like that, or f prime changes signs like this. Does f prime change signs at all? No. F prime is positive until 0 and then positive after that. F must increase, flatten out, increase. Might not be as smooth as you think, but nowhere. But we do have one critical point, x equals 0. My derivative is 0. Okay? I mean, I don't even give you like tick marks here. We'll call that 1. We'll call that 1. Where do we have relative extrema? When f prime changes sign, f will change directions. F prime changes sign here, here, and here. X equals -1, 0, and 1. F prime changes signs from negatives. Oh, shoot. Also here and here. So if this is like -1, -2, and this is 1 and 2. I got them all. I got y, and these are a little bit too advanced. Like this graph. Make sure you're comfortable with this graph. This graph. This graph. Make sure you're comfortable with those graphs. You can change sign at a 0. You can change sign at an undefined. I do change signs from negatives to positives to negatives to positives to negatives to positives. Okay? Negatives to positives. Negatives to positives. Min. Min. Max. Min. Max. Min. It's probably a crazy graph, but that's it. Mr. Mess is out. Later. Have a great long weekend.